this given rational fraction may be expressed in terms of different simple fractions, that is 3 by x plus 1 plus 2 by x minus 1 is called resolving into partial fractions. The degree of numerator is 3 and the degree of denominator is 2 for x. So therefore degree of x in the numerator is greater than the degree of x in the denominator. Therefore this is an example for a improper fraction. This improper fraction can be expressed as a sum of a polynomial. What is a polynomial here? This is the polynomial. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the temple of excellence. Today in this session I am going to take very important and simple chapter, that is partial fraction. So in this chapter we are going to get one 5 marks question. So no 1 mark, 2 marks, 3 marks, nothing, only one 5 marks question from this chapter for the point of examination. So you will get only one 5 mark questions. Now, so only one 5 mark questions you will get from this. Now, what are the contents, what are the topics we are going to study in this is, so introduction, polynomial function, rational function and its types of rational function. What is a rational function and the types of rational function? Improper functions as a sum of a polynomial and a proper fraction. Improper fractions as sum of a polynomial and a proper fraction. Now, let us know regarding what is the meaning of a partial fraction. So, any given rational fraction may be expressed in terms of different simple fractions which are called as partial fractions. So, that is any given rational fraction. Any given rational fraction can be expressed as f of x by g of x. Any given rational fraction may be expressed in terms of simple fractions which are called as the partial fraction. So, this f of x by g of x can be expressed as a simple fractions which are called as the partial fraction. So, consider for example 3 by x plus 1 plus 2 by x minus 1, sum of two simple fractions. So, if you simplify this, on simplifying this, let us take an LCM. So, that is 3 divided by x plus 1, 3 divided by x plus 1 plus x plus 1 plus 2 divided by what we have in the denominator, x minus 2. Take LCM. So, here LCM is x plus 1 into x minus 2 is the LCM, cross multiplied 3 into x minus 2 plus 2 into x plus 1. So, this is 3x minus 6 plus 2x plus 2 divided by the denominator is same, x plus 1 into x minus 2. So, this can be written as 3x plus 2x is 5x, minus 6 plus 2 is minus 4 divided by x plus 1 into x minus 2. See this? So, what is this equal to? 5x minus 4 divided by x plus 1 into x. That means, thus this expression 3 by x plus 1 plus 2 by x minus 2 is nothing but the partial fraction of this 5x minus 4 divided by x plus 1 into x minus 2. So, this given rational fraction may be expressed in terms of different simple fractions, that is 3 by x plus 1 plus 2 by x minus 1 is called resolving into partial fraction. So, this fraction, the rational fraction is converted into two simple fractions, sum of two simple fractions, that is called as a resolving into partial fraction. Now, let us consider one more example. 5x minus 4 divided by x plus 1 into x, same problem. Therefore, in general, 5x minus 4 by x plus 1 into x minus 2 can be written as 3 by x plus 1 plus 2 by x minus 2. This process of splitting a given rational fraction is called resolving into partial fraction. So, resolving 5x minus 4 divided by x plus 1 into x minus 2 into 3 by x plus 1 plus 2 by x minus 2 is called, the process of splitting is called as the resolving into partial fraction. Now, here let us consider a polynomial function. Now, polynomial function. So, what is a polynomial function? Any expression of the form a naught x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 etc. an where a naught is not equal to 0, where a naught, a1, a2, an are all constants, are called polynomial in x of degree n. So you might have been studied the linear equation, that is a degree of 1, x is equal to 1, degree of x is 1, quadratic equation ax square plus bx plus c is equal to 0, degree is equal to 2, cubic equation ax cube plus bx square plus cx plus d is equal to 0, a cubic equation, that is the degree of x is 3. So in general, a polynomial equation, any expression of the form a naught x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 3 etc. an is called a polynomial equation in x of degree n. Right. Now, let us consider, for example, 3x to the power of 7 minus 7x raised to 5 plus 13x cube plus 8 is a polynomial equation of degree. What is the highest power of x? X power is 7. So this is a polynomial equation of degree 7. Similarly, let us consider this example. So here x square plus 5x plus 6 is a polynomial in x of degree 2. So the degree of this is equal to 2. The degree is equal to second order. So degree is equal to 2. Suppose, for example, for degree of 1, we are going to write 2x plus 4 is equal to 0. The degree of x is equal to 1. Here the degree of this equation, x square plus 5x plus 6 is a polynomial equation of degree 2. The degree for this is 2, second order. Whereas for degree 1, we are going to write the equation as 2x plus 4 is equal to 0 is a polynomial equation of degree 1. All non-zero constants are a polynomial of degree 0. Now, let us know regarding what is a rational function. Rational function and a rational fractions. Rational fraction or a rational function. Now, if f of x and g of x are two polynomials in x, if f of x and g of x are two polynomial functions in x, then any equation of the form f of x divided by g of x, where g of x is not equal to 0, denominator is not equal to 0, is called a rational function, or it is also called as a rational fraction or rational function. So any equation of the form f of x divided by g of x, any polynomial of the form f of x by g of x, where g of x is not equal to 0, is called as a rational function, or it is also called as a rational function or a rational fraction. Now let us consider, for example, 8x square minus 5x plus 2 divided by 3x cube plus 4x minus 9 is an example for a rational fraction or function. Similarly, x plus 7 divided by x square plus 6x plus 1 is also an example. Or we can also write x square divided by x square plus 2x plus 3. This is also an example for a rational fraction. So, any equation of the form f of x by g of x is called a rational fraction. Now, let us move on to the proper and improper fraction. Proper and improper rational fraction. Proper rational fraction and improper rational fraction. So, a rational fraction f of x by g of x is called a proper fraction if and only if the degree of numerator polynomial is less than the degree of a denominator polynomial. If the degree of x in the numerator is less than the degree of x in the denominator, then such a polynomial is called as a proper fraction. Such a fraction is called as a proper fraction. The degree of numerator of a polynomial is less than the degree of denominator. For example, x square plus 2x plus 4 divided by x cube plus 5x square plus 3. This is an example for a proper fraction, proper polynomial, because the degree of x is 2. So the degree of x in the numerator is 2, the degree of x in the denominator is 3. So numerator degree is less than the denominator. Therefore, this is example for a proper polynomial fraction or a proper fraction. Similarly, one more example, we can also write 2x minus 1 divided by x square plus 3x minus 1. This is also an example for a proper fraction. The degree of x in the numerator is 1 and the degree of x in the denominator is 2. So therefore, the degree of numerator is greater than the degree of denominator for x. Therefore, these are example for a proper fraction. In general, if the degree of the numerator of a polynomial is less than the degree of the denominator of a polynomial, such a fractions are called as a rational fractions, are called as proper fractions or proper polynomials. Now, let us take next one, improper. A rational fraction of the form f of x by g of x is called a improper rational fraction if and only if the degree of numerator in the polynomial is greater than or equal to, if the degree of the numerator is greater than or equal to the degree of denominator polynomial, such functions are called as improper fractions. So, the degree of numerator, for example, x cube plus 4x square minus 1 divided by x square plus 2. This is an example for improper fraction because the degree of numerator is 3 and the degree of denominator is 2 for x. So, therefore, degree of x in the numerator is greater than the degree of x in the denominator. Therefore, this is an example for a improper fraction. So, even this is also an example for a improper fraction. Right. Suppose if it is like this, x square plus 4x minus 1 divided by x square plus 2. This is also an example for an improper fraction because the degree of x in the numerator is 2. Degree of x in the denominator is also 2. So, what is the condition? The degree of numerator must be greater than or equal to, the degree of numerator of a polynomial is greater than or equal to, then such a polynomial function is called as a improper rational fraction. So, in general, for a proper fraction, the degree of numerator is less than the degree of denominator. For improper fraction, the degree of numerator is greater than the degree of denominator or even equal to the numerator and the denominator degrees. That's it. Now, here, improper fractions as a sum of a polynomial and a proper fraction. So, how to express this? How to express this improper fraction as the sum of, see here, the degree of numerator and denominator are same. So, therefore, this is an example for an improper fraction. So, this improper fraction can be expressed as a sum of a polynomial and a proper fraction. So, sum of a polynomial and a proper fraction. Very simple. Just divide x square plus 1 divided by x square minus 5x plus 6. You will get a proper fraction and a sum of a polynomial. Okay. Now, let us take an example. Divide x square plus 1 divided by x square minus 5x plus 6. Now, let us divide x square plus 1 by x square minus 5x plus 6. Let us divide this. So, here we have x square plus 1. So, just multiply by 1. So, what we will get? 1 into x square is x square, 1 into 5x is 5x, plus 1 into 6 is 6. Subtract this. If you subtract, what happens? Minus, plus and minus. Plus x square minus x square gets cancelled. This is 5x. Minus 6 plus 1 is minus 5. So, how to expand this? This can be written as, so therefore, this x square plus 1 divided by x square minus 5x plus 6 can be written as 1 plus this 5x minus 5 divided by x square minus 5x plus 6. That's it. 1 plus 5x minus 5 divided by x square minus 5x plus 6 is nothing but a sum of a polynomial and a proper fraction. See, this is a proper fraction because the degree of x is 1 in the numerator and the degree of x in the denominator is 2. So, degree of numerator is less than the degree of denominator. So, therefore, this is a proper fraction. So, improper fraction can be expressed as a sum of a polynomial. This is a polynomial and a proper fraction. So, as I told, so here itself, that is, any all non-zero constants are polynomial of degree 0. So, this is a polynomial of degree 0 and this is a proper fraction. So, sum of a polynomial and a proper fraction, right? So, how to write this is nothing but a polynomial plus a proper fraction. That's equal to a polynomial and a proper fraction, right? Now, move on to the next problem. Same type. 3x square minus 4x plus 7 divided by x plus 7. This is also an improper fraction. So this improper fraction can be expressed as a sum of a polynomial plus a proper fraction. Let us divide this 3x square minus 4x plus 7 by x plus 7. Since we have 3x here, just multiply by 3x. So 3x into x is 3x square. Again plus 7 3s are 21x. Subtract this. This becomes minus and minus. Plus 3x square minus 3x square gets cancelled. Minus 21 minus 4 is minus 25x, and this plus 7 as it is. Minus 25x plus 7. So if you want, you can divide again, simplify this. Now just multiply by minus 25. So minus 25 into x is minus 25x. Minus into plus, it is minus 25 into 7. 25 into 7 is minus 175. Now just subtract. This becomes plus and plus. Plus 25x minus 25x gets cancelled. So 125 plus 7, that's equal to 175 plus 7 is equal to 182. 182. Okay. So therefore this can be put as the polynomial. What is a polynomial? 3x minus 25 plus proper fraction, that is equal to 182 divided by 182 divided by x plus 7. This is a sum of a polynomial and a proper fraction. That's it. Okay. So very simple. What is the problem here actually is just we are expressing this improper fraction as a sum of a polynomial and a proper fraction. So let us divide 3x square minus 4x plus 7 by x plus 7. What is the quotient remainder you are going to get? So if you divide 3x square minus 4x plus 7 by x plus 7, just multiply by 3x first. 3x into x is 3x square. 3x into 7 is 21x. Subtract this. Minus 3x square plus 3x gets cancelled. Minus 4 minus 21 is minus 25x is equal to 25x plus 7 as it is. Again multiply by minus 25. Minus 25 into x is minus 25x. Minus 25 into 7 is 175. Again subtract. This becomes plus and plus. Minus 25 plus 25x gets cancelled. 175 plus 7 is equal to 182. So 182 is the remainder. So therefore this improper fraction can be expressed as a sum of a polynomial. What is a polynomial here? This is the polynomial. 3x minus 25 plus the remainder 182 divided by x plus 7. So you know the division algorithm. So here remainder, quotient and the dividend. So 3x minus 25, therefore this can be written as 3x minus 25 plus 182 divided by x plus 7 as the sum of a polynomial and a proper fraction. Now this is very important. Now next let us move on to the next problem. 5x square divided by x square plus 4x plus 3. Okay, same here also, just express this improper fraction because the degree of numerator and denominator are same. So improper fraction as a polynomial, this can be expressed as a polynomial function plus a proper fraction. Express this as a polynomial and a proper fraction. Now very simple. Divide 5x squared by x square plus 4x plus 3. So divide x square plus 4x plus 3. So this 5x square is divisible by this. Now since here it is 5, we have x square, multiply by 5, that's all. 5 into x square is 5x square plus 5 4s are 20x plus 5 3s are 15. Subtract. This is minus, minus and minus. These two gets cancelled. What we have? Minus 20x minus 15. Minus 20x minus 15. Right. Now that's it. Now this can also be written as, if you want you can write minus out 20x plus 15. Now therefore, so polynomial plus a proper fraction. So polynomial plus a proper fraction. So therefore this can be expressed as 5 minus 20x plus 15 divided by x square plus 4x plus 3. This is how we are going to express 5 minus 20x plus 15 divided by x square plus 4x plus 3 is a polynomial plus a proper fraction. See here, proper fraction, the degree of x is greater in the numerator compared to the denominator. So degree of x in the numerator is 1, in the denominator it is 2. So therefore this is a polynomial and a proper fraction. Hope you followed. That's it. Very simple. See, just divide 5x square from x square plus 4x plus 3. Since here it is 5, we have multiply by 5. 5 into x square is 5x square, 5 4s are 20, 5 3s are 15, subtract minus minus minus, minus 5x square plus 5x square gets cancelled, minus 20x minus 15, you can take minus out, minus of 20x plus 15. So therefore 5x square by 5x square plus 4x plus 3 can be written as 5 minus this 20x plus 15 divided by x square plus 4x plus 3. This is a polynomial and a proper fraction, sum of a polynomial and a. This is how we are going to resolve into partial fraction. So these are few examples for converting an improper fraction into a polynomial and a proper fraction. Hope you followed. This is very important method. That's all regarding today's session. Let us take with different types of problems in the next session. Thank you. Thank you very much.